So we're gonna look at section 2.2 algebra functions. So algebra functions is just combining functions together using basic operations that we already know: adding, subtracting, dividing, and multiplying. So if you look here, I have f plus g. So I'm just going to add f plus g of x, and then I will break it down to f of x plus g of x. So if I was given some function, some function f of x is equal to some output, and then g of x is equal to some output, and I would just add everything after the equal sign. So whatever is after the equal sign for f, I will write that, and what you have after the equal sign for g, I will just write that and add it together. So we're just doing basic operations with functions. And then if I wanted to subtract, like f minus g of x, I would just take everything after the equal sign and just subtract that. And when I have f times g of x, so f times g, and we rewrite it as f of x times the function of g of x. And then I would just take everything after the equal sign for f, and then I would take everything after the equal sign for g and just multiply it. And then if I needed to divide it, I would take everything after the f and after g. And the only thing is, when we have a fraction, we always have to set restrictions. So you see x cannot equal to 0, g of x cannot equal to 0. So whatever you have in the denominator, you will set equal to 0, and you want to exclude that number from your domain, because that number is going to make the function undefined. So you just want to make sure you set the restrictions for that. So everything else, we just adding, subtracting, multiplying, and dividing functions. So just look at that in real life. The functions are always going to be given to you. There's nothing you have to memorize. You don't have to memorize any formulas or anything like that. So the functions are always going to be given to you. My screen went berserk for a second. So these are your functions. F of x is equal to x plus 1. G of x is equal to the square root of x plus 3. So when I look at my example here, I need to add f plus g of x. So I kind of broke it down. You just want to take your f of x plus your g of x. So my f of x is x plus 1. And my g of x is the square root of x plus 3. So now I just add this information. So when you look at it, I have x plus 1 plus the square root of x plus 3. You cannot add, regular numbers with radicals. So there's nothing I can really do with this one, but leave it as x plus 1 plus radical x plus 3. Because I have one x inside of the radical, and I have a regular x that's outside. You cannot combine those. So this is where you have to stop. So you just take everything that's after the equal sign and just add it. So they're going to tell you to add f plus g of x, and we always expand it. But if you don't want to expand it, you can just take everything and just start adding from the point right here. So just let me know if you have any questions. You can type or raise your hand. There's a little raise your hand button. So I'm going to use the same function. In example 1b, they want me to find f plus g of 6. Now I can use the information from the previous problem, but I'm just going to rewrite it as a fresh new one. So I have f of 6 plus g of 6. In the other problem, I had f plus g of x, and they just split it up as f of x plus g of x. So we just do the same thing with the 6. We put f of 6 plus g of 6. So what I need to do is before I add them, I have to input the 6 into each function. So if I have f of x is equal to x plus 1, and that's 6 in here, I get 7. So when I replace x with 6, I put 6 in, and I get 7 for my f of 6. Now I'm going to do g of 6. So g of 6, and my output is radical x plus 3. Everywhere I see x, I'm writing 6. And then 6 plus 3 is 9. Take the square root of 9, I get 3. So now I have 3 for g of 6. So just add that together. 7 plus 3, get 10. So f plus g of 6 is equal to 10. So just stop me if you have any questions. So just remember with these problems, you're just taking everything that's after the equal sign and adding and subtracting or doing whatever operation that they want you to do. On example 2, they want us to find the domain. So if you remember from earlier lessons that the domain, we have 2 restrictions, if you can recall. And we have a fraction. We always have to set the denominator equal to 0, and then it cannot be that number. And then the other restriction is when you have a radical, and that has to be greater than or equal to 0. And then your domain would be whatever number that is greater than or equal to 0. And then anything else that you have is all real numbers. In this problem, they want me to find the domain of f plus g, f minus g, f times g, and f over g, or f divided by g. So before I do the domains of these combinations, I just need to find the domain of the regular functions first, because that is how I determine my domain when I combine them. So if I look at f of x is equal to x squared minus 4, it's not a fraction and it's not a radical, so the domain of the first function would be all real numbers. Then looking at g, it's not a fraction, it's not a radical, it doesn't have any of that, those operations in there, so that's also our real numbers. Now, if I were to add f plus g without even doing the work, I can determine my domain based on already knowing the domain for each function. So if I add f plus g, since f plus g, well, since f is all real numbers and g is all real numbers, if I add f plus g, then the domain of that will be all real numbers. Because even by just inspection, I can tell that I don't have any radicals in it. I don't have any fractions in it. So whatever number I were to put into each function, I could never get the function to be undefined. So it has to be all real numbers. The next one, f negative g or f minus g. If I were to subtract f minus g, I will also get all real numbers because it's the same situation as f plus g. F is already all real numbers, g is already real numbers. So if you put them together, they keeping it real. So they are real when they get together. And f times g, same situation. When if I were to multiply f times g, I cannot get a fraction. I cannot get a radical. So that's all real numbers also. Write it in red. I'll write it down over here. Looks like a little test tube. And then f over g, that's the tricky part. But we play no games in math. But sometimes things are tricky. So I have f over g. So f is x squared minus 4. And g is x plus 2. When I combine these two functions, and I'm using division for this, dividing or a fraction, now I have a situation. So I need to make sure that I exclude any numbers that's going to make this function undefined. And know that when I have a fraction, I have to set the denominator equal to 0, only the denominator, because that affects, my domain, that affects my fraction. It would make it undefined if I had a 0 in the denominator. So I don't want that. So I want to set the denominator equal to 0. And when I do that, I solve for x, negative 2. So x cannot be negative 2. And I want to write it in my infamous interval notation. I would erase the board, but if I erase the board, it erases everything. So I have to squeeze everything in there. I haven't figured out how not to erase everything. So if I write this into notation, I get negative infinity to negative 2. And it gets a parentheses because I have to exclude negative 2 from my domain because I don't want it there because it's going to make my situation undefined, and I don't want to be in the situation when I'm undefined. I want to be in the situation where it's complicated. Not undefined, but just a little complicated, a little unrest in my relationship. So this would be my notation for the domain of f over g. So just stop me if you have any questions about it. Give you a little time to let it marinate a little bit. In example 2, we're going to use the same functions. And we're just going to add, because now they want us to add them. Before we're finding the domain of the functions. Now we want to add them. So remember when we add them, f plus g of x, I already started breaking it down. F of x, g of x, f of x is x squared minus 4. Remember, I'm writing everything after the equal sign because sometimes students, they start writing x's and doing all kinds of stuff like that and come up with some new math. Math is already created, so we don't need anything new because I don't feel like learning anything new. Now I need to add f of x, g of x, so I did that. Now I just need to combine like terms. And sometimes you have students, they'll do x squared plus x and get x cubed. That's totally wrong. The only time you can get x cubed if you are multiplying. So I have seen this time and time again that students, for some reason, they get confused and they start multiplying and doing different operations, and it's incorrect. So we just combine in like terms. So I have x squared, and I don't have another x squared, so I just write x squared. Then I have an x, I get plus x. And then I have a negative 4 and a positive 2. A negative 4 and a positive 2, I subtract and then take the sign of the larger number, which is negative, and then 4 minus 2, or negative 4 plus 2 is negative 2. And this is all she wrote for this one. You don't have to factor it, just like that. And so you just take your function, everything after your f of x, everything after your g of x, and just add them together, combine like terms. So it's everything that you have done since preschool. So just let me know if you have a question, raise your hand. Now, example C, we want f minus g of x, and there's always a special kick when you are subtracting. There's always this extra thing you always have to look for because subtraction is dangerous. So I have everything after the function, so x squared minus 4, and then x plus 2. That's the spice of life here. So I have that negative. So that negative needs to multiply everything that's in this expression x plus 2, because x plus 2 is married, it's together, so you just cannot tack it on. You cannot tack your negative on to just your x. You have to do something to each term. So my negative is like a -1. We don't write that, but we want to multiply each term inside of the parentheses by a negative, or just change each term by the negative. Get x squared minus 4 minus x minus 2. So you just have to make sure this negative is going to change the sign of each term. So x was positive, it becomes negative now. 2 was positive, it becomes negative now. So whenever you have an expression, they are married. So whatever you do to one, you have to do it to the other one. And it's like multiplying by a -1. So now you can combine like terms. The only thing like are the numbers that I have. So I have x squared minus x, a -4, and a -2 is a -6. F minus g of x is equal to x squared minus x minus 6. So let that marinate a little bit. Any questions? Anybody? C, no. H to the no. So it's just basic operations. It's just taking your functions and doing basic operations that we use every day. We always add and subtract and divide and multiply something. Now, in D, we want to multiply. Who's writing on my board? Make it a little bit bigger. So f of x times g of x, so everything after the equal sign, x squared minus 4 times x plus 2, put parentheses. I can't erase this, so it's going like that. So now I have everything in F, everything in G, and I need to multiply. So I need to FOIL. I have two binomials. And I just need to multiply it by FOIL, or you can use the distributive property if you are more comfortable with that. So when I multiply these two functions together, I get x cubed plus 2x squared negative 4x negative 8. So again, you just multiply the first times the first. X squared times x is x cubed. When you multiply exponents, you add them. So that's how I got x cubed. And then my outer would be 2 times x squared. So 2x squared. And then my inner negative 4 times x gives me negative 4x. And then my last negative 4 times 2 gives me negative 8. And there's no like terms. Remember, don't start adding these exponents together because we're adding and subtracting, we aren't multiplying. So it stays like this. This will be your final answer. So just let that marinate for a minute. Now here we need to divide. So I write everything that's after my f of x, which is x squared minus 4. Everything that's after my g of x, which is x plus 2. And you remember, x cannot be negative 2. We determined that when we found the domain. And now I can factor. So when we have a fraction, we want to see if we can factor the top and the bottom. So here I can factor the top. This is the difference of squares. Remember that? And now I get x plus 2, x minus 2 over x plus 2. Now I can cancel top and bottom only. I can cancel out x plus 2, x plus 2. So f over g of x is x minus 2. So let that marinate for a while. So before we go into the difference quotients, we're gonna take a little break and save that for Friday. So if you don't have any questions, I just want to go on to things that you're going to need for this quiz 6. Yeah, when I erase, I got to erase the whole board. So this came from JIT. I don't remember which one, but these are the JIT that we did before the coronavirus. So here I need to rationalize the denominator. And we know that we cannot have a radical in the denominator, so we need to get rid of it. But before I do that, I need to break up each radical separately. Sometimes I look to see if I can reduce the fraction first, but I cannot reduce it to a whole number, so I just separate it. And now I need to get rid of the radical, so I just multiply the top and the bottom by the radical, because the radical times itself is just that number that's inside. So radical times itself is just that number, so radical 2 times radical 2 is 2. And now on the top, when I have radicals with the same indexes, I can just write it under the same one. And there's nothing I can break up. So at this point, I can just multiply it. 15 times 2 is 30 over 2. You cannot reduce here because you cannot reduce a regular number into a radical. So rationalize the denominator. You just have to get rid of the radical that's in the denominator by multiplying that radical by your denominator and your numerator. Any questions on that one? Multiply. And when we multiply radicals, not multiply 6 by 14 because you're going to get some big number. So it's just better to write each number under one radical. And then just break each number down to prime factors. 6 is 2 times 3, and 14 is 2 times 7. I'm going to rewrite it so I can get the 2's together. 2 times 2 times 3 times 7. So my index is 2. The index tells me how many of the same factors I'm looking for, or how many of the same repeated factors. So it tells me how many of the factors that I'm looking for. So here I'm looking for 2 groups of 2's, even though that's a 2, but I'm looking for groups of 2. So then cross out 2, a 2 here and a 2 there, and then I have a 2 outside, a big 2 now. And then anything that's left inside, I just multiply it and get 21. 3 times 7 is 21. So we have to look at index. It tells me how many of the factors, the same factors, the group of factors that I'm looking for. And once I find that, break it down. And some math classes, they just try to find the perfect square and they do it like that. But in our class, we broke down each number to prime factors and we got our answer. Any questions? For an odd index, you can have a negative inside. So it's okay to have a negative inside. You cannot have a negative in a square root or something that's even. So it's okay to have negatives. But I want to break it up into 3 negatives because I want my radical to be positive. So I want to break up -8 to -2, -2, -2. And then I want to break down my x's. I have 3 of them. So now I'm looking for 3 repeated factors. So I have 3 -2's. I have 3 x's. So this information, these numbers come out of your radical. So I get a -2, and then I get an x. And so bye-bye to the radical because everything came out. So when you simplify this, your answer is -2x. So odd can be negative. Stay away from these odd radicals, they negative. If we are trying to simplify radicals, you have to make sure, yeah, you have to break it all the way down to R prime numbers. So if you had like 8, you can do 4 times 2 and then break it down. And then the index, I'm looking for repeated 2 repeated numbers, and then for that number it comes out. So you just want to break everything down R prime numbers, and based on the index, that's how many repeated factors you are looking for. So here I have this exponent that has a fraction in it, and they want me to write it into radicals. And remember when we did this, when I look at this exponent, the power is on the top, is for your numerator, and your index is the denominator. And this is what goes inside. Your base goes inside the radical. So A would be inside the radical, and my index is 2, so I don't have to write it. I don't have to write that 2 there, but, and then I raise it to the power. And actually, I want to write this one differently, because we can, when you have a number, you raise it to the power. No. On the quiz, you don't have to write that 2. I don't even give you the option to write the 2, because you probably have to select the symbol that's in my math lab, so you don't have to. So this one I'm gonna write differently, because since it's just a variable, I'm gonna attach the power to the radical. I mean to the variable. So now I have the square root of a cubed, which I can simplify more now to a times a times a. My index says I'm looking for 2 repeated factors. So a comes out. I don't know, in my math lab, I never did a problem. I never did a work in my math lab. I don't know if there's going to be a 2 option or not, but if it is, yeah, it means the same thing. Okay, so let's do another one. My math lab, It's always giving you these papers. So I need to break down 175. I think that's 25 times 7. So when I'm subtracting, indexes have to be the same, so the indexes are the same. So what I need to do before I subtract, radicals have to be like. So at first, sometimes students look at this and say, oh, well, they're not like, there's nothing I can do, and they move on. Oh, you have to simplify each radical and then see if you can move on. So here, I have 5 times 5 times 7. Remember the big 2 is outside. And I can bring out a 5. So 2 times 5, I get 10. This color probably isn't a good choice, but I already started writing. So now I have like radicals. I have radical 7 here. So only thing I need to do is take the numbers that are in front, subtract them. I get 5, and just keep my like radical. Okay. Now I'm just looking at problems that I generated through my math lab, so they are all over the place. So now we're going back to a problem with the radical notation. So looking at this problem, I see that I have a positive exponent, a negative exponent. I need to make it positive. So in order to do that, I have to write it in the denominator and make it positive. And once there, that's when I can change it to a radical. The 256 inside. My index is 4. And it's being raised to a power of 1. So now I just need to simplify inside this radical. You can come up with 2 numbers that multiply. I think 16 times 16. And then I need 4 of something, so I want to keep on breaking it down. 16 is 4 times 4. And then this 16 is 4 times 4. And I don't have to keep on going because I need 4 the same number, so I have 4 of them. And then I just cross it out and get 4. Now the numerator stays 1, and then this 4 is in my denominator. So my answer is 1 over 4 or 1/4. So just let that marinate for a second. So a negative exponent, we have to change the positive by dropping it down into the denominator. And then we want to change it into a radical because they want radical notation. And then we just break everything down and we get forth. And this would be the last one. So here they want us to multiply. So we multiply using FOIL. And then we just take into account our radical rules for radicals. So I multiply my first terms together, 2 radical 3 times radical 3. And then my outer -6 radical 7 times 2 radical 3. My inner, a positive radical 7 times a radical 3. And then my last negative, because this is positive, this is negative, so that makes that a negative radical 7 times 6 radical 7. So now I just need to simplify. Here I know radical 3 times radical 3 is radicals multiplied by itself. It's just that number that's inside. So that becomes 2 times 3, which is 6. And then I do this part right here. Multiply the -6 and the 2, I get -12. And then the radical 7 times 3 is 21. And then go to this piece right here. Radical 7 times 3 is 21. And I'm multiplying so I can multiply the numbers. When we are adding or subtracting, radicals have to be like. We are multiplying. They don't have to be like, but the indexes have to be the same. So I'm just able to multiply it. And then when I go here, this last part here, I have this is like a -1. So -1 times a +6 gives me a -6. Radical 7 times radical 7. This gives me 7. And so now, let me see what I have. I have 6. And then this is like a 1 in front. So that's -11, radical 21. These are like radicals right here. Well, I didn't do it yet. Just get, because I'm just going to bring it down here. But you do that. I just didn't do it yet. So now I have then my like terms in the middle. And then I went back and multiplied -6 times 7. You can do it before, just a habit. My math calculations, I just jump ahead to different pieces. And now I have to continue to do anything that's like 6 and -42 gives me a -36 minus 11 radical 21. Do not combine these because you cannot combine a radical, and a regular number. And this is how you simplify that. If you have any questions, let me know. So these are the type of problems that's going to be on the quiz. I'm going to stop the video, and then I would be in the classroom to take any further questions.